All right, we have 4x minus equals 11, and we have 8x plus 6y equals 11. And the directions say determine whether the graphs of the equations are parallel, perpendicular, or neither.
What's perpendicular mean?
Means at a right angle. Hopefully the walls in your house are perpendicular to the ceiling or the floor, like these. Otherwise you have slanted house. And I'm going to, because what we have to do is we have to compare their slopes. So I'm going to write them side by side instead of stacked, because in order to compare their slopes, I'm going to rewrite them both in slope-intercept form. Because once I do that, then I can look at their slopes. And if their slopes are the same, then I know they're parallel. And if their slopes are what we call negative reciprocals, then I know they're perpendicular. And it could be neither. So the first thing I'm going to have to do is rewrite both of these in slope-intercept form, which is to get them y equals. So let's move our x term. And we're actually going to have to, I'll just do it all at the same time. And then that's going to leave me negative 4y equals negative 4x plus 11. Okay. And then on this side, I'm going to have 6y equals negative 8x plus 11. Now on this equation on the left, I've got to divide everything by negative 4. And my equation on the right, I'm going to have to divide everything by 6. So that's going to leave me y equals, and then I have negative 4x over negative 4 would be 1x, so x, and then plus, yep, 11 over negative 4. Or I could have put minus 11 over 4, and honestly it doesn't matter because I don't have to worry about the y-intercepts. I just have to compare the slopes. So the b in this doesn't even matter to us. And then on this one, it looks like I get y equals negative 8 over 6. If I reduce that, you know what, it doesn't even matter because I can already see my slope. But negative 8 over 6, let's just reduce that to, what, negative 4/3?
Would it?
And then plus 11/6. What's your question?
I'm a little confused.
So my slope here is 1. And my slope here is negative 4/3. Which means, to answer the question, are they parallel? No, because they're not the same. Are they perpendicular? No, because they would have to be negative reciprocals. So since this one's negative 4/3, that one would have had to have been a positive 3/4. So negative and flip it. But it's not that either. So to answer the question, the answer would be neither.
Got a question.
Uh-huh. So 17, we have the problem y to the negative 9 times y to the negative 3. Now on your formula sheet, you have your exponent rules, properties of exponents in the first column there. And this problem is the most similar to the top one, the very first one listed. A to the m times a to the n, and it says equals a to the m plus n. So in other words, when your bases are the same, what we add our exponents. So negative 9 and negative 3 would be negative 12. So we use that first property. However, we now have a negative exponent, which is not considered to be simplified. So we have to use another exponent property. So if you go down the list, you'll see one that says a to the negative n. And what did they do to make that a positive exponent?
They put a 1 over it.
So this is 1 over y to the 12th.
Oh, that's right.
So even if you don't remember why we do that, as long as you can read your formula sheet, you know what to do. Okay, so this is there to help you on the final. Now on Wednesday, when you're working some practice problems, if we need to talk about why this happens, I can go over that again, not a problem. But I just want to make sure that you guys know how to read this formula sheet. Otherwise, it's not going to help you at all. Because 19 is another exponent rule. We have t to the 4th over t to the 8th. So looking at your formula sheet, which one does this look like?
Looks like the
1, 2, 3, the fourth one down. It's a quotient, it's a division problem. So what does it look like we do with our exponents in that situation?
we subtract.
We subtract. So it would be 4 minus 8, which is negative 4. But because it's a negative exponent again, we got to use that negative exponent rule. So our final answer would be 1 over t to the positive 4.
That's the fourth one down.
Mm-hmm. So on this one, we had to use, I called the same base quotient rule. The bases are the same. That's another critical part to this. If those bases were not the same, we couldn't use any of these rules. We can do anything. Okay, the bases have to be the same in order for us to use these rules.
Is that the 80?
Okay, so 21, we have 5 over x in parentheses to the 4th power. And so we're still simplifying. And so according to our properties here, now this looks like the one with parentheses. In other words, everything will get that 4th power. So 5 to the 4th over x to the 4th, and we can actually simplify 5 to the 4th. Would you agree that that is a number?
Yes.
I mean, it's 5 times 5 times 5 times 5. So it is a number. So you could put that into your calculator and actually calculate that. You can either type in 5 times 5 times 5 times 5, or you can use your exponent key. So you get 625 over x to the 4th. But since it's in parentheses, that's why both the numerator and the denominator get that 4th power, because it's the whole set of parentheses getting raised to that power, not just the 5 and not just the x, both parts.
That's only.
Okay, this next one always confuses me, whether to go to the left or to the right.
Ah, well, we will solve your confusion. This is a scientific notation number, 6.88 times 10 to the 4th, and it says convert to decimal. So yeah, how do you know? Do you go to the right or the left? The easiest way, it is negative 4. So if it's negative 4, that implies we're getting a smaller number. If it's positive 4, we're getting bigger. So that's the way I like to remember it. So if we're going smaller, then that tells you you're going to the left 4 places. So I get point, and then I move it so it looks like 1, 2, 3 zeros, 6, 8, 8. Because I'm getting smaller. If that was a positive 4, then instead of moving to the left to make it smaller, I would have moved to the right to make it bigger.
Okay,
Okay?
good.
Yeah, those can be confusing if you don't remember. Okay, so on this one, we are subtracting polynomials, which really is just combining like terms, but you have to be careful whenever you're dealing with subtraction. Because remember, we're subtracting everything in that second set of parentheses. So, yes, we're combining like terms, but you have to remember to subtract. So instead of having to remember to subtract, I like to just change it to an addition problem. Because any subtraction problem is the same thing as adding the opposite. So I like to just go ahead and change it to add, and then I opposite all my signs inside my parentheses, and then it's just combining like terms. So I'm going to start with, because I want to write it in descending order, I like my exponents to decrease. So it looks like I have 5x to the 6th, and I have a minus 3x to the 6th, which gives me 2x to the 6th. And then I have actually nothing else that can combine.
X to the 5th.
Oh, did I write it down wrong?
Yeah.
I did write it down wrong. Okay, I was like, because I put a 4 here, and that should be a 5. Okay. So, yeah, I've got a 10x to the fifth, and I have a minus 13x to the fifth, which leaves me negative 3x to the fifth. And then I have numbers. So I have 14 and 2, which leaves me plus 16. So 2x to the 6th minus 3x to the 5th plus 16 is our answer on 25.
So that's what the answer would be.
Yep. That's as far as you can go, because none of those are like terms, so you can't combine any more of them. 27 says multiply. So when I multiply and I have a monomial on the outside, I have to distribute to everything on the inside. So negative 5x to the 5th times 9x would be negative 45x to the 6th, because we have x to the 5th times an x to the 1. We add our exponents. 5 and 1 is 6. Then I have to take negative 5x to the 5th times a negative 6. So negative times a negative is a positive 30x to the 5th. And that would be my final answer. Negative 45x to the 6th plus 30x to the 5th. And 29 is a binomial times a binomial. Which means we have to FOIL. So my first terms, 3x times x is 3x squared. My outer terms of 3x times 11, 33x, very good. And then my inner terms, negative 12 times x, negative 12x. And my last terms of negative 12 times 11, negative 32. That's one that always gets me. I always have to think about that one. And now I just combine my two middle terms because they're like terms. So I have 3x squared plus 21, 132. And that'd be my final answer. 3x squared plus 21x minus 132. And this was, oops, I didn't label this. This was 29.
In other words, that's, you subtract 12x from 33x.
Yeah, I combined my like terms. 33x and 12x are like terms, so I combine those. X to the 4th plus 3x squared plus 5 divided by x squared plus 1. So I'm going to write it as a long division. So we've got x to the 4th plus 3x squared plus 5 divided by x squared plus 1. And now we have to ask ourselves, what times x squared is x4?
X squared.
X squared. So x squared, change colors here. So x squared times x squared is x4. And x squared times 1 is x squared. And then I have to subtract that from up above. What you want to happen is you want your first terms to drop off. You want them to go away. So you have to multiply by something that will give you a term that you can subtract and it becomes 0. So x to the 4th minus x to the 4th, I think we could agree is 0. So x to the 4th minus x to the 4th. Now 3x squared minus x squared is 2x squared. And then we bring down the plus 5, and then we start the process over. Yes?
You said, yeah, 2x squared plus 5.
Uh-huh.
All right. If you got a plus, it would be plus 3. And you got a x2.
3 minus 1 is 2.
That's imaginary 1, right?
Yes.
Oh, okay.
3 minus 1.
That's kind of like how that happened.
Now, let's do the next part. So now we have to think what times x squared, because that's the number that we're dividing by, gets you 2x squared. 2. So, plus 2. And now I have to take that 2 and multiply it by everything that I'm dividing by. So 2 times x squared is 2x squared. And 2 times 1 is 2. And now I subtract that. So that's going to give me 2x squared minus 2x squared is gone, and 5 minus 2 is 3. Now I don't have anything else to bring down, so I'm done. So what's my final answer? Well, I have x squared plus 2, and then we write our remainder as a fraction. So 3 over your divisor. Just like if you were doing long division, it was all numbers. Okay, you would always write your remainder as a fraction. So that would be our final answer. Looks kind of funky, but that's it. X squared plus 2 plus 3 over x squared plus 1. 3. And the directions say factor. We have x squared minus 2x minus 120. So remember, when there is